Welcome to the Sports Science Dudes. I'm your host, Dr. Jose Antonio. You can find our podcast on Spotify, YouTube, and Apple Podcasts, also on Rumble. Our special guest today is Jeff Young, and actually we're going to do something slightly different this show, but let me tell you a little bit about Jeff. He has his master's degree in exercise and sports science, and he's currently a doctoral student getting his EDD in kinesiology. He's also a certified strength and conditioning specialist. He's also ACSM-EIM. He works primarily in medical fitness and has worked at world-class facilities such as Duke, UCLA, and Beth Israel Medical Centers, and as the founding fitness coordinator and faculty practice provider at Mount Sinai Medical Centers Center for Health and Healing in the great city of New York City. So it's the most comprehensive urban-based academic integrative medicine and medical fitness facility in the U.S. Currently, Jeff operates his own company in New York City, which implements and oversees medical fitness and post-rehabilitation patient services at a clinical facility in Manhattan and provides virtual medical fitness services nationally. So, Jeff, welcome to the show. However, we're going to sort of turn the tables here, and actually you are going to be asking me questions, and today we're focusing on protein, correct?
That is correct. So just to give your listeners a little bit more background, and one of the primary audiences here is going to be my students, because I also teach several courses at the City University of New York, or CUNY, at their York College institution in Queens, New York. So my students are watching this and probably realizing now or at the beginning of this lesson plan that, oh, this is part of Dr. Antonio's podcast, which is really cool. So let me just start by saying that on behalf of myself, students, institution, we really appreciate that. This is a treat. And yes, so that your listeners can know, this is actually part of a lesson plan and a chapter in the book that we use called Discovering Nutrition on protein. And you obviously, I know that you're very passionate about this. I've done a lot of research on it, and I really look forward to picking your brain on this topic. And I know that our students are going to really benefit from this.
Yeah, this will be fun. And like you alluded to, I've done a bit of protein research, and I think students will find it interesting. There's a lot of myths surrounding protein in general, and I think they'll learn quite a bit from this.
Absolutely. And so on that, and actually on that note, we're definitely going to be getting into some of those myths. I want to ask you some questions regarding that, but let's start off with just some basic fundamentals as it relates to this chapter. So my first question is, can you explain what amino acids are and the difference between essential and non-essential amino acids? And can you also, along with that, talk about why protein is such an important macronutrient?
Yeah, I think I would definitely start with the essential and non-essential amino acids, and certainly in the diet category or nutrition category, things that are essential, whether they're essential amino acids or fatty acids, et cetera, are things that you need to consume in your diet because you don't make them. So you have 9 essential amino acids. Everything else is not essential, meaning your body already makes it. And you could think of the amino acids as the building blocks of proteins. Now, just to clarify this, when the average person thinks of protein, they just think of foods like, well, steaks, protein, chicken's protein. In fact, in the body, human body, animals, et cetera, proteins play an integral role in pretty much everything. For instance, if you were to take out fat mass and water from the human body, you're basically left with protein. I mean, protein is needed for, it's structural, for instance. Your bones are made of protein, skeletal muscle made of protein. Enzymes, protein, your red cells are protein, all of the transport molecules that are part of the cell membrane are protein. So really, protein is ubiquitous. It's in every part of your body. And from a diet standpoint or nutrition standpoint, we tend not to focus really on the cell biology of protein, because really, when you're talking about enzymes and structural components, that's really more cell biology. We focus on the diet aspects, meaning, for instance, the essential amino acids. I don't know if there's a mnemonic device that you have your students memorize, but what I have my students do is memorize Private Tim Hall, PVT TIM, and then small h, small a, LL. So Private Tim Hall, P is phenylalanine, V is valine, T is threonine, the next T is tryptophan, I is isoleucine, M is methionine, And then you have H and A, and then people talk about, are they essential, conditionally essential? Well, let's just start with histidine and arginine. Most people would consider arginine conditionally essential. And then the last two, the L and the L of private Tim Hall, that's lysine and leucine. So if you can remember the essential amino acids, then basically, the rest are non-essential. So for instance, if I buy a product, a whey protein or amino acids off the shelf, I tell students, just look at the label. And if it says there are essential amino acids in it, you should be able to just sort of rattle it off in your head. It's like, oh yeah, that's essential, that's essential, that's essential. So it makes it easy, certainly as a consumer, but I think students should at least be aware that you have essential, you have to get it in your diet, and you have non-essential, which your body naturally makes.
Love it. And yeah, I wasn't familiar with the, what did you call it again?
It's private Tim Hall.
Yes, I was not. So I love that. I really appreciate that as well.
Now, here's the funny part. And students, when I ask the question, they'll not remember the amino acids, but they'll say, well, private Tim Hall. I'm like, no, that's not the answer. That's not the answer. You're supposed to remember the names.
Yeah, that's funny. And then as a quick follow-up, can you also just talk about, well, you know what? I was going to ask if you could talk about why protein is such an important macronutrient, but you know what? We're obviously going to get to that. So let's skip that for now.
Okay.
And so my next follow-up question for you is, can you elaborate how protein plays an important role in weight management through its effect on satiety? This is something that I'm very passionate about because, as you alluded to when you said my bio, which I realized it was way too long, I should have shortened it up. But in any case, as you alluded to, I'm definitely involved in medical fitness and the obesity care and medicine world. So I'm passionate about this too, but I'm definitely looking forward to your response.
Yeah, when you look at the preponderance of evidence and you compare, carbs versus fat versus protein, there's a couple things that makes protein really good for weight management or even losing fat mass. It has a very high thermic effect, meaning that if you were to consume 100 calories of protein, you will burn anywhere from 20 to 30 calories just to digest and assimilate the protein. Whereas carbs and fat are typically 10% or less. I mean, let's say fat is the lowest and carbs around 5 to 10%. So the thermic effect of protein is quite high. But also it does impact satiety. There's plenty of data showing that protein seems to be the most satiating of the macronutrients, meaning if you consume, let's say, an isocaloric or isoenergetic amount of protein, carbs, and fat, protein seems to, in a sense, kill your appetite more than carbs and fat. Now, that's in the aggregate. There are people who come up to me and say, when I consume fat, that seems to kill my appetite more than protein. And yeah, there will be those, there's going to be that variation, but in the aggregate, protein seems to be the most satiating. So I was interested particularly in the pragmatic aspect of that. So, okay, so if you consume a lot of protein, and let's say you're on your typical diet, let's say it's 2,000 calories, and the only thing you do is, hey, what if I just consume an extra couple hundred calories and it just be protein? So in this case, it would be a protein shake or whey protein. What would happen? Well, the typical answer is, well, if you're eating more calories, you'll gain weight. Well, no, because some of the studies we did here at Nova Southeastern University, we did these studies, God, 7, 8, 9 years ago. And we found that if you just introduce a lot of protein, it actually promotes a loss of fat mass. And I think part of it is it produces such a high thermic effect. And let me just give you an anecdote as to how much of a thermic effect it is. I had this one subject, a small female. She must have been maybe 100 pounds, 105 pounds. And when we did the post testing, she was one of the best subjects. She actually, if you do human studies, you like those subjects that actually do what you tell them to do. It's like she actually did exactly what we asked her to do. It was 2 grams per pound of body weight or 4.4 grams per kilo of protein, which is a lot. She maintained it. And she said, I mean, she had kind of a funny story. She said, I was so hot all the time. Just to fall asleep, she said she couldn't have covers on them. She would just turn the fan on full blast just because she was constantly sweating and hot, which is part of the thermic effect of protein. You're just burning calories because why? You can't store protein. So people cannot treat protein calories the way you treat carb calories. Now, certainly a calorie is a calorie. However, what you put in your body isn't always treated identically. So protein calorie, when it goes in your body, is not treated the same as a carb calorie or a fat calorie. So people need to understand that if you just make minor adjustments in the percentages of carb, fat, and protein, you can actually promote a loss of fat mass without, and this is the kicker, without decreasing total caloric intake. And I think people find that confusing, but it's because protein is treated differently by your body.
I am a sample of one, but I'll say that I lost just shy of 35 pounds from July of 2023 until March of this year. So I'm currently at about 193. I'm 6 foot, 193, and that's actually my kind of my fighting weight, like in the upper 180s, low 190s is what I
You're
spent
pretty
a
lean
lot of.
now. You're pretty lean.
Yeah, yeah, and I had gotten up to 225, and during the pandemic, and my fault type of stuff and everything. And without a doubt, I increased my protein intake, and for the first time, I grew up skinny and all that stuff, so I didn't. I was one of those people that didn't really need to worry about it. Watching my, like, actually thinking about how many calories I was taking in and stuff like that. But I'm 59 now, so those days are over for me. In any case, long story short, that absolutely applies to me. And again, I know I'm just a sample of one, but that is absolutely what I did. I mindfully upped my protein, and I
Yeah.
mindfully reduced my carbohydrates. And it actually has been pretty easy for me to maintain this weight now, for the last 6 months or so. And I think a lot of it has to do with what you just said.
Yeah. What you describe is actually what a lot of individuals, not just in the physique sports, but even the performance sports, where let's say you're a distance runner or a cyclist or a swimmer, where body weight and body composition are both important. And just by a simple, I tell people, do a simple switch, take out 50 grams carbs, put in 50 grams of protein. And without a shadow of a doubt, they end up losing fat mass that improves their body comp. So what you describe, it's always great when what people do in a real world and what happens in a study actually match. It's like, whoa, this is kind of cool.
Yeah, absolutely. Awesome. All right, let's move on to the next question, where we'll get into more, or continue to get into some practical stuff. And this is also something that I'm passionate about, and I imagine you are as well. The U.S. recommended dietary allowance for protein is zero point 0.8 grams per kilogram of body weight. And you've performed research on protein needs for different populations like athletes and older adults, and the International Society of Sports Nutrition, which, my students need to understand that you're CEO and co-founder of the International Society of Sports Nutrition, correct?
That is correct.
Yeah.
We're actually going to have our 22nd annual conference next year in Delray Beach, Florida. If you love the beach, you should come.
Absolutely. And let me also say that, and I know I'm getting off my question here, but the Facebook group has like 30 plus thousand members, if I remember correctly. So in any case, I'm going to direct my students to that as well, because I just think that they should be involved in your organization one way or another, and for educational purposes. But back to the question. So you've performed research on protein needs for different populations like athletes and older adults, and the International Society of Sports Nutrition has a position stand on protein and exercise. So can you break down what you consider an optimal protein range for different populations, and how people can practically achieve it?
Yeah, this is interesting because I've worked almost entirely with people who exercise, and I've done very little in sort of the general population of sedentary people. So with that said, when you look at the RDA at 0.8 grams per kilo body weight per day, is that enough for someone who doesn't exercise? And this is where I actually flip the question, because I've given this talk to like groups of physicians. I always say, if you're not exercising, then none of this stuff matters. Why? Because exercise is the single most important behavior that you could do that will improve your health. And it's my bias, but it's a fact. I mean, exercise is the best thing you could do. Now, they'll still throw the question back, well, what if you don't exercise? Is that enough protein? I'd be like, yeah, you're not going to be deficient at 0.8 grams per kilo. Will it be ideal? No, because even if you increase from 0.8 to, let's say, 1.6, so that's doubling it, which, to be honest, isn't that hard to do, your body composition will probably improve. And as you know, in this country, body composition is a problem. 70% of the population is either overweight or obese. So just by eating more protein and keeping calories the same, you're probably going to be better off. So So that's general population. Let's talk about the athletic community. And this is where it gets really interesting. Back when I was doing my master's degree at Kent State University, my advisor was Peter Lemon. He actually was the initial person to look at protein requirements in endurance athletes. And he said, this is back in the mid 80s. He said, what, endurance athletes need more protein than the general population. And it made sense because you still got to recover. But it took from the 1980s really to now. I mean, we're talking 20, 30 years later, where now we have such a huge volume of data that for people who exercise, you should probably get at least up to 1.6 to 1.8 grams per kilo. Now, this is what's interesting about the ISSN position stand. If you look at the position stand versus what a lot of people recommend in my community. So the position stand, whether it's ISSN or the Academy or whatnot, it ranges roughly between 1.2, 1.3, up to 2.0, maybe as high as 2.2 grams per kilo. If you're like trying to cut weight or lose weight. Now, me personally, and this is where people, they're kind of interested. They find it interesting that I personally tell athletes that they should get at least 2.2 grams per kilo or 1 gram per pound. And that should be the baseline, not the top end, the baseline. And they're like, wait a minute. The ISSN position stand, they have a range that actually starts at around 1.5. And if you look at the majority of review papers in this category, you're right. They start somewhere around 1.4, 1.5. I mean, we're sort of quibbling over things, and it goes as high as 2 grams per kilo. But based on, and this is where there's an art and a science to this stuff. When you work with athletes, you sort of, you play around with these recommendations and you see what works. And I think you can't go wrong going higher, meaning, at least 2.2 grams per kilo. However, there's not a lot of studies on that. Why? And this is what's interesting. It's hard for a lot of people to eat that much, believe it or not. They have to be really motivated. However, I like to look at things pragmatically. I'm not a purist. Like if for instance, if studies are done only in college age males and females, let's say they're 18 to 25 years old, does that mean I can only give advice to college age men and women? What about the endurance athlete that's 35 years old who wants to run a 5K, set a PR in 5K instead of running it in 25 minutes? He or she wants to run it in 23 minutes. Okay, well, they're not college athletes, but principles should apply. What about the 40-year-old bodybuilder who wants to gain, 5 pounds of lean body mass? Should I wait for the study on 40-year-old bodybuilders? No, you could still apply the principles you find in, let's say, college age students to those who are not in that category. So I think 2.2 grams per kilo should be the baseline. However, keep in mind that is based on my personal experience working with athletes as well as the literature. If you're a purist, if you're an absolute purist and you look at the literature, generally at the bottom, it's somewhere around 1.4, 1.5. So that's what a lot of people recommend at the bottom. And at the top, it might go as high as 2.0 grams per kilo. Now, I'm also not a minimalist. It's interesting, a lot of scientists that, not necessarily close colleagues of mine, but I'll read what people write. They tend to be minimalists. It's sort of like, well, what's the least I could do to get an effect? Yes. And my view has always been, wait, what's the most you could do to be as good as possible? Yes. And sometimes the least you could do, like for instance, let me give you this example. If you train 2 or 3 times a week doing aerobic exercise, you'll make tremendous gains, particularly if you start off untrained. If you train 4 times a week, you'll still make improvements. You train 5 days a week, okay, the improvements aren't quite as much, but you still improve. So to me, if your goal is to be a lot better at something, you should do everything possible to reach that goal. Not let's do the minimum. What's the least I could lift? What's the least I could run? What's the least protein I could eat? It's like, no. How about aim for something higher? So that's where I differ from a lot of scientists. I tend to be a lot more pragmatic about this than just, well, what's the literature say? What's the literature say? Well, I know what the literature says. It doesn't mean you have to follow it exactly. Treat the literature as a roadmap. I mean, you and I are old enough. Do you remember when you had to open up paper maps and you're like, oh, geez, you had to write down your directions to figure out where to go somewhere? I'm like, that's what this is like. It's like, okay, well, I can take the highway or I can take the turnpike. There are many ways to get to a destination. And that's why I don't think you should be so strict in following the literature.
You said two things there that, man, I just really hits home, and I also heavily agree on. Number one, the minimalist
Yeah.
uh, comment. I'm nearly the polar opposite of a minimalist, and you're right. The pendulum seems to be swinging that way, whether it's in nutrition or fitness or whatever,
Yep.
health. What's the minimum I can do? And
Yep.
I kind of look at things as like a continuum of, I just call it a continuum of optimization. So what's
Yep.
least optimal that we can get by, the minimum effective dose, and
Yeah.
what's most optimal. Let's look at the most optimal, as you just alluded to.
Yeah.
Let's look at the most optimal end and try to strive for that. So I'm really glad that you touched on that.
And now
Uh,
there are people who they're like, hey, just tell me the least amount I could do. I mean, when you work with Gen Pop, right? General
yes,
population. However, if you work with people who it doesn't matter, and I'm talking about people who just have a goal. They don't have to be professional athletes, but if they have a goal, whether it's to lift more weights or run faster, you can't be a minimalist. You have to sort of do everything you can for that to help them reach that goal.
that's right. And here's another way to word it. I have two colleagues that, you know that we have a medical fitness podcast, which hopefully you're going to be a guest. Well, you're going to be a guest if you agree to be a guest. But in any case,
Absolutely.
um, one of the things that we talk about, and one's a physician assistant, one's a physical therapist, and then me, and one of the things that we all talk about and agree on is that the patient, client, or athlete in front of you has the right to know best practice. Let's inform them of what best, or not, and that's just another way of saying what's optimal, right?
Yeah.
Let's inform them of best practice, and now they're an informed consumer, and then they can make their own decision. Although if they're an athlete, they need to be listening to their sports coach or writers
Right.
or sports nutritionist or wherever the case may be. So it's a little different there, but you get the point. So I'm really glad that you touched on that because it's so
Yes.
important to hear.
Yeah. Absolutely.
And then another thing that you touched on, which I'm just glad that you did, was just mentioning principles. And so when I was an undergrad at Penn State way back in 95 and 96, and my academic advisor was Dr. Bill Kramer, who's widely considered, premier sports scientist in the world. And when I found out that he was my academic advisor in my junior and senior year, and that's one of the things that he started drilling into my head is become a principles person. Learn the principles. There's all these different methods and stuff like that, but learn your principles and don't stray from them. If you learn the principles and don't stray from them, you likely won't go wrong. But if you forget your principles or don't know them and all you're concerned with is all the different methods out there, you're going to get lost. And I think that's a thing that's really happening in nutrition, fitness,
Oh,
medicine, etc.
oh my. No, that's absolutely true. I think a lot of individuals, they'll go on social media and they'll see this person says, well, you gotta do hit training and do the Norwegian method, 4x4 hit training. And they're thinking, oh, there's something magical about the Norwegian method. It's like, no, there are multiple ways to do high intensity interval training. That's just one way. And again, if you go back to principles, as long as you know the principles of exercise training and adaptation, you can come up with a myriad of ways to reach a goal.
Exactly.
And yeah, but people get caught up. They're like, well, just tell me exactly what to do. Well, I can
Exactly.
tell you what to do for now, but we're going to have to change it down the road.
That's right. And
Yeah.
I know we're straying a little bit here, but that, the whole Bloom's taxonomy thing, and if all you want to know is what to be told what to do, you're kind of forgetting the whole like
Yes.
understanding, applying, be creative with it,
Yeah.
etc. So yeah,
Yeah.
no, I really appreciate this. And something you alluded to when you were answering the previous question, I just want to hit on with a little bit more clarity, detail, whatever. It is that sometimes we see protein intake recommendations expressed in grams per pound instead of per kilogram of body weight. So, is this approach valid in certain scenarios, or is the kilogram measurement a better standard?
Well, as my friends in the UK, Canada, and pretty much the entire world say, who uses pounds? I mean, that's it. It really is an American thing. I mean, and I'll be honest, I still think better in pounds than in kilos. If
Yes.
someone says something per kilo, I'm like, okay, what's that in pounds? Um, Even though I've been working with the metric system, my entire professional life. To me, it's whatever is easier for the consumer. I mean, certainly most Americans would prefer it in pounds. When I give talks, I usually I usually use both because some people like pounds, some people like kilos. Certainly, if you give a talk in Europe, they're not going to know what the hell a pound is. So you got to do it in kilos. But it really doesn't matter. I think however you express it, just make sure it's to the proper audience because If you're just talking to American bodybuilders, they're like kilos. Just tell me pounds. I don't want to know kilos. I don't even know what 100 kilos is. So just give me
Right.
pounds.
What about, is there a difference between someone who's how you would calculate protein intake needs with someone who's leaner versus someone living with obesity? What about that?
Yeah, that's a good question. When I give protein recommendations, people will ask me, do you give it based on what their target body weight is? Do you give it
Yes.
based on fat-free mass? And again, as a pragmatist, a lot of people can't get body composition assessed correctly anyway. So I give it based on their body weight. Now, I don't work with obese populations, but let's say someone is 300 pounds and really their weight should be 200 to 220, somewhere in that range. Question is, should the protein recommendation be based on 300 pounds or be based on 220 pounds? And here's what's interesting. If you actually base it on the 300 pounds, they're probably going to lose more fat mass. But this is the issue. It's much harder to eat 300 grams of protein than to eat 220 grams of protein. So I would give the range. So let's say they're 300 pounds. They want to get to 220. I would say, how about your target protein intake should be roughly 200 to 300 grams? So that gives them this wide range. So they don't feel like, holy crap, I can't hit 300. I can't even hit 250. But hey, you could hit somewhere 200 to 250. Anyone can do that if you treat eating, and this is a key, if you treat eating the way you treat training. No one, like for instance, a runner just doesn't wake up and go, I think I'll run 13 miles today. Oh, but wait a minute, I ran 13 miles yesterday. They should have a plan. Same with eating. Eating should be treated, it should be planned. So you can't just haphazardly be like, okay, I think I'll eat 200 grams today. It's like, well, I hope you know what you're supposed to eat to hit 200 grams. So, and I think that's a common mistake. People don't treat eating the way they treat training or exercise, when in fact, both require discipline, both require a plan.
You're killing me. I love it. Get this. I also teach a strength and conditioning course
Oh,
at Coney York College, and had Dr. Kramer as a guest lecturer earlier this semester. And one of his primary points to my students was, again, whether it's a patient, client, or athlete in front of you, have a plan, log the plan, because if and he basically said, and I'm paraphrasing him, but basically, if you aren't logging the plan, then you don't have much of a plan. So have
right.
a plan, log the plan, and then in the case of exercise, and I would imagine this applies at least in some sense to nutrition, periodize the plan. So that you're in any case.
Yeah,
But the main point here being
you gotta
that
have a plan.
have a plan, log the plan, and that there are, as you talked about when you introduced me, my master's is in exercise and sports science, and so I obviously had a sports nutrition course. And one of the things I think about, I'm also a certified strength and conditioning specialist, so it's like my whole credential background relates to athletes, and yet my experience relates to the clinical and more sedentary population. And I think that the that we need to bridge that gap, and there's way more similarities between how you will approach an athlete and how the I actually think that this is the reason, a big reason why we have an overweight and obesity problem in the United States, is because people aren't uh logging, planning, and all the things that will help us hold us accountable, etc.
No, that's a good point. In fact, there's data showing that people who are overweight tend to underestimate energy intake and
Abs
overestimate energy output. So
Absolutely.
yeah, and oftentimes when you have them, and I'll ask people like for my students, I'll say, hey, could just log your diet for 1 week. That's it. It's not that hard. And I say, don't lie. Because I personally don't care what you eat. If you eat Pop-Tarts, great, but I just need to know exactly what you're eating. And when they start logging it, they realize, wow, I'm eating stuff that I don't even remember I ate, like a lot of junk. People just sort of forget they eat junk. And I said, yeah, unless you're aware of what you're eating, oftentimes you just mindlessly eat, and you don't even, like yesterday, what'd you eat? Oh God, I don't know. And so people tend to be sort of mindless about what they eat. And that's why, you know, programs get derailed because they don't treat eating with the same discipline as they treat training.
So as we speak, and now, flash forward to my students watching this, this is one of the major projects that they do, major assignments in the course is it's actually a 4-day food log, 2 days during the week and 2 days during the weekend. And I build it out so that there's then reflection. So when they after they read the new and the protein chapter, for example, and then learn about protein, then they have to add to their assignment and reflect back on, compare your protein intake and your sources with what you learn versus the food log that you just took, a couple weeks ago. And we do it again with carbs and with lipids slash fats. So yeah, and again, going back to when I was a student at Penn State, that was one of the most memorable things I did in a nutrition course. And what a wake up call it was for me. I was like, holy crap, I didn't know I was eating this much, because I was able to eat that much because I'm biking all over campus and playing
Yeah.
basketball 4 days a week and stuff like that. But I had no idea I was eating that much, the crap I was eating. It's a real eye opener. So absolutely, we need to do this.
Yeah, that's true. It's a great exercise for students because it makes them a little bit more self-aware.
And then at the end of the semester, I always again, this is an asynchronous course, so there's discussion boards, and I'll always ask them, what did you enjoy about the course, what did you not like, etc. And most of the students will say that the food log and the reflections and the associated discussions were some of their most favorite things about the course. So
Right. Oh, that's good. That's good.
absolutely. Let's move on. Protein quality is a hot topic, especially with plant-based diets on the rise. Some argue that animal proteins are superior to plant-based proteins. And what's your take on that debate? And how should people approach protein sources as it relates to this?
This this is kind of a funny question because in if you look strictly at the data, and again, knowing I'm not a purist, animal-based proteins are better than plant-based proteins. Particularly if you look at, God, there's got to be dozens upon dozens of a acute feeding studies. So short term, they feed animal-based, plant-based. They measure X for X number of hours muscle protein synthesis. And guess what? Animal-based proteins are better. They produce a much higher rise in MPS or muscle protein synthesis. They're like, okay, well then animal proteins are better. Now, I'm not even a vegan, yet I'll even argue the vegan side. I would say, well, nobody eats just one meal a day of a shake. Nobody does that. Number two, we all eat mixed meals. We're all eating, well, most of us are. I mean, I know students who like skip breakfast, maybe barely a lunch, and then they hog out at dinner. But let's assume we're eating 3 meals a day. We're all eating mixed meals, meaning we're getting carbs, fat, and protein at every meal. So does it matter that whey protein works better than soy protein post-workout when throughout the day you're eating mixed meals of carbs, fat, and protein? To me, the paramount consideration is total protein intake. So let's say you're close to 1 gram per pound. Then I'd say you're good. In fact, I don't care what kind of protein you're eating, whether it's soy, whether it's fish, you're good. However, if you're closer to the 1 gram per kilo, I'm switching over to kilos. If you're closer to the 0.8 to 1 gram per kilo, quality matters. And in that case, animal-based, milk-based proteins are a lot better. Or what about if you're dieting? Let's say you're cutting weight, whether you're trying to make a weight class in weightlifting, a weight class in wrestling, a weight class in any of the fight sports. That's when quality matters most, because now you're just cutting calories. So let me summarize that. If you're not cutting calories or trying to make weight, total protein intake matters. If you're reaching 1 gram per pound, you're good. I mean, I tell people it doesn't matter where you're getting it from because you're getting enough protein. If you're trying to make weight for a sport, or you're trying to, cut weight in some form where you're cutting back calories, that's when quality matters. And in that case, yes, animal-based proteins are better. They are better than plant-based proteins. So again, as you know, there's nuance and there's context to it. So it depends sort of where you are in that scheme.
Absolutely. And a related question is there such a thing as, well, it's related, but we also could probably, veer off of this a little bit with like kidney health and stuff like that. But is there such a thing as too much protein? Like at what point, if any, can excess protein be problematic? And how would someone even know if they're over consuming?
Well, the simple answer to that is we don't know what too much is. Although this is it's kind of maddening, but kind of funny at the same time. On social media, you often hear, well, that's too much protein. Some athlete will say, well, I'm getting, 300 grams per day. And I'm like, well, that's like 2.5 to 3 grams per kilo. Well, that's a good amount of protein. Not many people can do that. Now, we did a follow-up study on male bodybuilders over a 2-year period, and they were eating up to 3.5 to 4.0 grams per kilo. That is a lot of protein. We also did their blood work. They are healthy as can be. In fact, I wish my blood work was as good as theirs. So at least, and here's the caveat, at least in guys, and we didn't study any women for 2 years. We studied women for 1 year, but guys for 2 years. At least in guys who and this is the caveat, they train really hard. Guys who train really hard and eat a lot of protein, they are healthy as can be. Now, we followed women for a year. Women who eat a high protein diet for a year, also very healthy. But again, these women train really hard. So when people say, well, what if my uncle or aunt decided to eat that much protein? My answer is, they're not gonna. You know why? Because it's hard. And the only people who can eat that much protein are people who are so motivated based on they want to perform well in a sport that they treat eating the way they treat training. And most humans just cannot do that. In fact, I would posit that eating that much protein might be harder than training because you got to do it all day.
Yeah. And would you say that that another thing that plays and maybe even alluded to it, but that plays a role in all this is how the body will I'm trying to think of the right way to word this. For lack of a better word, the body just reacts to food differently when you're training versus when you're not training. And yeah, I don't know if I'm wording that. Can you understand my question or?
Well, in a pragmatic sense, I don't think we'll ever know what happens when sedentary people purposely eat that much protein because they just won't.
Right. Okay.
It's sort of like, can I get a sedentary person to run a marathon without training? Well, I guess if you point a gun to their head, they'll run a marathon, but they're just not gonna.
Okay.
Yeah.
All right. Let's move on to the another hot topic, red meat.
Red meat.
So red meat often gets mixed reviews in terms of health, and I would love to know your perspective on consuming specifically unprocessed red meat. Do we have enough research to make a solid conclusion about the benefits or the risks? Unprocessed.
It's interesting. Well, as you know, these are all based on observational studies. And we all know the drawbacks of observational studies where you're just looking at large populations. You're looking for what happens when this group eats a lot of red meat, this group doesn't, et cetera, et cetera. The data is equivocal. But again, this is where it gets a little tricky because, okay, are there people who just eat a lot of red meat who don't exercise? I would guess there would be. But what about all the people who exercise a lot and eat red meat? Okay, does exercise offset any possible effect of the red meat? Perhaps. Now, we do know that white meat consumption, chicken and fish, there is no association. So there's something there, but again, it's one of those things where, okay, how frequently are you eating red meat, and are you also engaging in other behaviors that might be good or bad for you? My general take is that if you're eating red meat, but you're also exercising and doing these other behaviors that are good for you, I don't think it matters. Now, processed meat, obviously, the data seems to be much more conclusive there in that it's probably not a good thing to eat processed meat. But as far as unprocessed red meat, I'm still not convinced that it's particularly bad for you. Particularly, again, going back to we eat mixed meals, breakfast, lunch, dinner. It's not like I'm eating red meat breakfast, lunch, and dinner. You might be eating red meat once a day or maybe once every other day, or some people, maybe just once every third day. So to sort of summarize that, I don't think there's enough data to say it's bad for you, particularly when you're eating it with other foods as part of a mixed diet.
Gotcha. Okay. I have two more questions for you. The next one is on protein timing. So could you clarify the role of protein timing? Does it really matter when we consume? You actually hit on this earlier, but maybe we'll just be a little bit more focused on this one. Does it really matter when we consume protein in relation to our workout or daily activities?
This is always a fun question. Does it matter when you consume protein? Okay, the simple answer is no, as it applies to post-workout protein. However, as I said earlier, total protein intake is what matters. So if your goal is to get 200 grams of protein, let's say eat 4 times a day, you get 50, 50, 50, 50. So 50 grams of protein. I mean, that's ideal, but nobody does that. But let's pretend. should you consume protein post-workout? My answer is always, yes, you should. And they're like, wait, you just said it doesn't matter. I'm like, it's not so much the timing that matters. What matters is that it gives you an opportunity to consume food, i.e. protein, so that it elevates your total protein intake throughout the day. And in fact, when strength coaches ask me, like for instance, at the college setting, you can't really control what college kids eat because they, let's face it, they eat like crap. They skip a lot of meals. So I tell them, hey, do simple stuff. If you can just hand them a shake once they leave the weight room and say, just drink this before you go to your dorm room, whatever, that will contribute to the total protein intake. So it's not so much the timing, it's the convenience of doing it after you work out, when it's like you're either driving home or walking to your dorm or walking to your apartment. It's like, just drink it. I mean, I always have a protein shake after I train. Why? Because one, I'm kind of thirsty, and two, I'm just sitting. I'm like, I'll just drink protein because I'm not going to eat, a hamburger after I work
Right.
out. I want something that somewhat satiates, my thirst, but also I'm getting good quality protein. So it's not so much the timing, it's the fact that it contributes to total protein intake. That's why it's important.
Okay, good. Dr. Antonio, that was actually the last question I had for you, unless you feel like we didn't cover something that you think is important for either your listeners or my students. So if there's anything that you think is important that we didn't cover on the topic of protein, please let me know.
Yeah, I think people will ask, well, what do you think is the best source of protein? And my answer always surprises people. I always tell people, they might say, is it beef? Is it milk? Because most of the data is actually on milk-based protein. I say fish. Now, a lot of people don't eat fish, but why fish? Well, fish, not only is it an excellent source of protein, it's an excellent source of fat. And for those of you who want to get some of the good fats, eat plenty of fish. Unfortunately, I have friends who will not touch fish at all, and they won't even touch fish oil tablets. I'm like, so you're getting zero omega-3 fatty acids? They're like, yeah, I don't like that stuff. It's gross. I'm like, huh, okay, well, And these are people who are scientists and they know. So even people who know what to do, they're
Right,
not going to do it.
right.
But I think fish is certainly the best source of protein. Actually, in fish also has the highest concentration of creatine. And creatine has a myriad of other benefits
Yeah,
related to lean mass, cognitive function, et cetera, et cetera. But I think that's important. And also, one of the problems with the protein category are the associated myths with it. The number one myth, and this is going back to when I was an undergrad, is that eating a high protein diet is bad for your kidneys. And we've done studies 1 year long, 2 year long, showing it has no effect on kidney function. If anything, the people who eat a lot of protein are super healthy. So I think we need to get rid of that myth, like protein's bad for your kidneys. It's just not. The data's not there. And even people are like, what about chronic kidney disease? Let's look at CKD. I'm like, if you actually look at the data, you might create a different set of problems if you lower protein intake so much. Now you're contributing to loss of lean mass. So now you're dealing with, okay, loss of lean mass, kidney function. But again, CKD or chronic kidney disease, it's not a population I work with ever. But just looking at it from a protein intake standpoint, it's kind of interesting. It's like, wow, maybe the recommendations aren't good. Maybe recommending too low an intake may also in the long run create issues that are worse. So I just want to put that out there, food for thought for your students.
I really appreciate it. And you're again going back to principles. I try to drill in my students' head in all the courses I teach that basic physiology is part of the principles that we need to know, and because then you can start thinking, and you just again talked about like the trade-off. There's a trade-off there, and when we know our basic physiology, then we can think about those things, and when we don't, then we don't think about it. And I'll also say that whether it's fortunate or unfortunate, my wife is Latina and she is a foodie's foodie, maybe even a foodie's foodie, and she's gonna love the fact that you just said we need to eat more fish. So guess what? I'm gonna be eating more fish. Not that's not a complaint. There's certain types of fish that I like, and if it's too fishy, I don't like it.
Right.
But in any case, she's really gonna appreciate this talk, and especially this part of the talk. So, but hey, I really appreciate your time. And I know we have another one coming up here in 2 or 3 weeks. So I look forward to our next talk about sports nutrition as well. But really appreciate A, your time, and B, allowing me to come on your show and take over your role.